Welcome back. In today's video, we are diving into Ohm's law. Whether you're building your own circuits or just curious about electric devices, this is a concept you'll need to understand. In 1828, German physicist George Simon Ohm studied the relationship between electric current flowing through a conductor and potential difference of voltage applied across it. The result of his research is what we call Ohm's law. So, what exactly does Ohm's law say? It tells us that electric current through a conductor is directly proportional to the potential difference across it, provided the physical conditions such as temperature and pressure remain unchanged. In simpler terms, the more voltage you apply, the more current flows through the conductor, as long as the physical conditions stay the same. Let V be the potential difference applied across the conductor and I be the current flowing through it. Mathematically, we denote it as V proportional to I. And constant of proportionality is R. So, V is equal to IR. Or we can also write it as V by I is equal to R. Here, the constant of proportionality R signifies the electrical resistance. Resistance is a property of a material that opposes the flow of current. It's like traffic jam for electrons. If you plot the relationship between the voltage and current for most metallic conductors, the graph is a straight line, as you can see. This means that the current increases as the voltage increases. The unit of resistance is called ohm. And here is something cool. 1 ohm is defined as the resistance when 1 volt of potential difference causes 1 ampere of current to flow. But not all materials behave the same way. Some materials like metals follow Ohm's law perfectly. These are called ohmic resistors. However, other materials like semiconductor diodes or vacuum tubes do not follow Ohm's law. These are known as non-ohmic devices. In fact, for devices like semiconductor diodes, Ohm's law doesn't hold true even at low voltages, which is why we see the curved IV graphs. Let's move on how we can understand the resistance in different conductors. There are few factors that affect resistance and you can explore them with simple experiment. In the first experiment, take a long conducting wire of uniform cross section. Cut out pieces of different lengths, say L1, L2 and L3. This makes sure that wires have same area of cross section. Connect L1 between A and B and note down the current through the wire. Perform the same experiment with wires of length L2 and L3 one by one. Let the currents in the wires be I2 and I3 respectively. As you can see, the graph of 1 by L versus I forms a straight line. We observe that longer the wire, greater the resistance, and therefore smaller the current. Mathematically, we can express this as R is proportional to L, where L is the length of the wire. So longer the wires offer, more resistance to flow of current. The second experiment, let's take wires of same length but different cross-sectional area, say A1, A2, A3, etc. Connect the wires between A and B one by one and note down the currents I1, I2 and I3 in each case. As you can see, the graph of A versus I forms a straight line. Wires of greater cross-sectional area allow great currents to flow. That is, wires of large cross-section area offer small resistance. Mathematically, R is proportional to 1 by A. That is, inversely proportional to cross-sectional area. So, what we conclude, wires with larger area allows more current to flow through them. So, combining these two facts, length and area, we can express the resistance of wire R proportional to L by A, and the constant of proportionality is rho. Rho is known as the resistivity of the material, and it is what determines how strongly a material resists the flow of current. It is called the specific resistance or resistivity of the material. So we can write rho as RA by L. The resistivity is a property of the material itself. It is the resistance offered by a wire of length 1 meter and area of cross section 1 meter square, and it's measured as ohm meter. On the flip side, the reciprocal of resistivity is called conductivity, sigma, and the unit is Siemens per meter. Resistivity depends on the nature of material rather than its dimensions, whereas resistance of conductor depends on its dimension as well as nature of its material. Let's consider an example. In our home, the electricity is supplied at 220 volts. Calculate the resistance of the bulb if the current drawn by it is zero point 0.2 milliamp, sorry, zero point 0.2 ampere. So we know that R is equal to V by I. V is 220 volt, I is zero point 0.2. Substitute. Simplifying this, we get 1100 ohms. Let us now look at a practical example. Two copper wires A and B have the same length. Diameter of A is twice that of B. Compare their resistance. We know that RA is equal to rho L by pi RA square. Similarly, resistance of another is rho L by pi. Here we have considered they are of same length. Considering the length to be L, also the resistivity of the same since the same material. So RA by RB is equal to, only this component is different. So we can write this as RB square by RA square. Given that diameter of A is 2 times diameter of B. This implies RA is 2 times RB. Substituting this, RA by RB is equal to RB square divided by 2 times RB square. Oops. Which is equal to 1 by 4. So we can write this as RB is equal to 4 times RE. So resistance of B will be 4 times the resistance of A. Let's move on to another example. So it's given the length of the conducting wire is 60 meter and its radius is 0.5 centimeter. The potential difference of 5 volt produces a current of 2.5 ampere in the wire. Calculate the resistivity of the material. So for that, let's find first the resistance. R is equal to V by I. Given V is 5 volt, current is 2.5 ampere. From this, 2 ohms. Now, given R is equal to 0.5 centimeter, length is equal to 60 meter, and area of cross section will be pi r square. Now that the resistivity rho is equal to R A by L, which is equal to R into pi r square by L. Substituting the things, 2 into 3.14 into 5 into 10 to the power minus 3. This one. Square. Let me not write it as square. 5 into 10 to the power minus 3 divided by 60. Simplifying this, this is 12. This is 6. Ohm meter. This is the resistivity. To summarize, Ohm's law relates voltage, current, and resistance. V is equal to IR. Resistance depends on conductor's length, area, and material. The material's resistivity determines how easily it allows current to flow, and conductivity is the inverse of resistivity. Thanks for watching. If you find this video helpful, don't forget to like, share, and subscribe. Have any questions about Ohm's law or resistance? Drop them in the comments below. I'll get back to you.